Bueno, buenas tardes, gracias a todos los presentes. A continuación seguimos con la conferencia El futuro es ahora, fábricas in situ, certificación de la manufactura. Primero el doctor Saúl Pineda Hoyos nos va a hacer una contextualización. Él es ex viceministro de Desarrollo Empresarial del Ministerio de Comercio, Industria y Turismo. Y su invitado especial, Mike Saxer, director de Ingeniería de Practeria en Sudáfrica. A continuación, le doy la palabra a Iván Sánchez, asesor en Economía Circular del Grupo Cargo, quien va a ejercer la moderación de este espacio. Gracias.
Por acá. Estamos bien. Buenos días a todos, bienvenidos. Para el Grupo Cargo es un gusto tenerlos acá. Vamos a estar hablando de certificación en la manufactura. Tenemos un gran invitado y me encantaría darle la palabra a Saúl. Saúl es ex viceministro de Desarrollo y es el asesor en producción de desarrollo de desarrollo sostenible en producción para el Grupo Cargo. Mi querido Saúl, la palabra es tuya.
Gracias, Iván. Let me start with a very special thank you for Mike for staying with us in this conference, and of course for your champion and brilliant cooperation in the introduction of this new technology 4.0 in Colombia. We are talking about mobile smart factory. And of course, también agradecer la presencia de todos ustedes en esta conferencia. Y quiero hacer un especial reconocimiento al liderazgo de Milena Jiménez, a quien invito a pasar al estrado, y a todo su equipo por estar liderando esta iniciativa en Colombia, que no es otra cosa que avanzar hacia la certificación de la producción a través de las tecnologías de producción por adición, es decir, en 3D. Ya no serán los contenedores moviéndose desde 13.000 millas, sino contenedores in situ, produciendo las piezas y las partes que requieren las empresas en Colombia. Es audaz, pero es un sueño al que ella le ha estado apostando y quiero destacar ese liderazgo de ella y de su equipo. Por favor, Milena. Y quiero hacer una muy breve introducción, porque aquí va a ser Mike de Practeria, quien será conferencista central en este evento, para señalar tres cosas que me parece importante enfatizar de las tendencias de la cuarta revolución industrial en Colombia, así como los retos y oportunidades que tiene el país, tanto de transformación productiva como de inclusión social en el marco de los objetivos de desarrollo sostenible, porque Tecnologías 4.0 nos habla ciertamente de dar el salto cualitativo en la política industrial, pero también el salto cualitativo en sostenibilidad. Y aunque la economía digital y de datos a la que está referida las tecnologías 4.0 están muy concentradas en el mundo, en China y Estados Unidos, también hay unas oportunidades enormes en esta coyuntura para países en desarrollo con el fin de cerrar brechas tecnológicas y, repito, hacer las oportunidades de transformación productiva e inclusión social. A lo largo y ancho de toda la cadena de las actividades de las tecnologías 4.0. Blockchain, ciertamente, inteligencia artificial, Internet de las cosas, por supuesto, automatización y de manera muy central, que nos ocupará en esta conferencia, el tema de la impresión 3D, el de la producción por adición. Su aprovechamiento productivo y de inclusión social requiere en este momento un elemento que me parece muy importante señalar con ustedes, y es de destrezas básicas, complejas y de carácter. Las primeras de ellas, allí en marrón, ustedes ven básicamente las destrezas fundacionales, las de formación básica, es decir, las destrezas alfanuméricas, de comprensión de lectura y de discernimiento más básico para poder acceder a las tecnologías 4.0. Pero vienen ahora las complejas, las que tienen que ver con el pensamiento crítico, con la solución de problemas y con un elemento que la Universidad de Harvard demostró como éxito de sus emprendedores: be nice, trabajar en equipo. Esto no solamente con matemáticas y Big Data, es también con sensibilidad por el trabajo en equipo y por un elemento clave que es la sostenibilidad. Hoy la sostenibilidad hace parte de las competencias complejas que se requieren en el mundo de las tecnologías 4.0. Y claro, cualidades de carácter, que es las que está imponiendo Cargog para avanzar en este proceso en Colombia desde su introducción: iniciativa, liderazgo y persistencia. Esas son, digamos, las destrezas básicas que requieren las tecnologías 4.0 y que tienen que ser ofrecidas desde nuestros institutos tecnológicos y desde nuestras universidades, lo que ya señala una importante barrera a la introducción de este tipo de tecnologías en Colombia. Y aquí me va a tocar actuarles un poco esta diapositiva, porque dice muchas cosas. Dice, por ejemplo, que la matrícula universitaria en economía, en administración y en contaduría sigue creciendo en nuestro país. Allí lo ven ustedes en azul, lo cual no es malo, si es que estuviéramos aplicando las nuevas tecnologías 4.0 en ese tipo de procesos formativos. Pero miren ustedes lo que está pasando en otros frentes de la formación. Simultáneamente, la matrícula en ingenierías cae entre el año 2010 y 2019, y cae también de manera persistente la matrícula en matemáticas y ciencias naturales, que son formaciones muy importantes al lado de las humanidades para garantizar que estas tecnologías se puedan abrir camino en el país. Por su parte, y tal vez esto es lo que más preocupa, en el último quinquenio, mientras la inversión en investigación y desarrollo se concentra en la adquisición de maquinaria y equipos, con un promedio anual de inversiones del orden de los $1.000 millones importando tecnologías, se mantienen en niveles bajísimos y marginales las inversiones en transferencia de nuevas tecnologías. Esto no es solamente con equipos, esto es con conocimiento incorporado. Y a ello hay que agregar la bajísima adopción de las tecnologías de información y comunicación en nuestras empresas. 1.000 millones de importaciones de bienes de capital, 20 millones de dólares anuales en el mejor de los casos, en todo lo que tiene que ver con inversión en transferencias de nuevas tecnologías y adopción de las TICs. Ahí es donde está el desafío, en formación, pero también en inversión desde nuestras empresas. Y concluyo para darle la palabra a Mike con un mensaje positivo. Por fortuna, en medio de estos desafíos, el país está en este momento avanzando en escenarios de apoyo, en mecanismos de apoyo para la incursión de los emprendedores y las empresas en los procesos de las industrias 4.0. Solamente les voy a hablar de 3 de ellos en los que ustedes van a encontrar oportunidades directas de apoyo. Sin duda, en el contexto de la cuarta revolución industrial, es importante que desde el año 2019 la Alcaldía de Medellín, con el Ministerio de Comercio y con el Foro Económico Mundial, hayan dado lugar a la creación del Centro para la Cuarta Revolución Industrial para América Latina, que si bien tiene todavía desafíos enormes por aquello de las convergencias políticas, ya empieza a hacer tareas importantes en materia de apropiación de las MIPYMES de ese tipo de tecnologías 4.0 en sus procesos productivos. Hay que avanzar mucho más, pero ya está en Medellín para América Latina y hay que aprovecharlo. En segundo lugar, desde el gobierno nacional hay un programa que a mí particularmente me encanta porque lo vi crecer y lo vi generar resultados. El programa Next de Impulsa, donde ustedes pueden encontrar diagnósticos en el uso y la apropiación de las tecnologías de manufactura avanzada, particularmente en aquellos que tienen que ver con las tecnologías 4.0 y que son por excelencia, procesos sostenibles y de economía circular. Y finalmente, hay que decirlo, y no puedo desaprovechar este escenario de Corferias para decir que en el marco del decreto 278 de marzo, apenas de este año, desde el Ministerio de Comercio, en una de mis últimas labores al frente del Viceministerio de Desarrollo Empresarial, creamos el marco jurídico para el modelo de zonas francas 4.0, que impulsan la exportación de servicios y que incluso le ofrecen a Corferias, a este tipo de escenarios feriales, la posibilidad de avanzar a hacer zonas francas de servitización de producción avanzada. ¿Y por qué no acoger aquí mecanismos de innovación muy poderosos como estos del Mobile Smart Factory que nos ocupa el día de hoy, con el fin de convertir este tipo de producción en zonas francas de servicios permanentes, parque, como los que efectivamente habilitamos en el marco de ese nuevo decreto? Así que tenemos desafíos, tenemos brechas, pero también tenemos oportunidades a partir de estas alianzas tan interesantes que nos ha generado Practeria, pero también Biofunction con Cargo Colombia, para que ustedes escuchen ahora, y gracias por el interés de esta muy importante presencia de todos, a Mike, quien hará la presentación de esta novedosísima tecnología que creemos tiene condiciones muy propicias para desarrollarse en el país en los próximos años, con un criterio, repito, de transformación productiva y desarrollo sostenible. Okay, Mike, I think you can go now to this lecture. Okay, thank you so much for staying with us.
Mike, can you hear us?
I can hear you guys. I'm having a little bit of problem with everything showing.
Okay, we're going to wait. There's no problem. We really
Please,
appreciate
can you
your
see
time.
my screen at all? Can you see my screen? I have done a screen sharing now. Can you see the screen?
Can you share your screen or you can't?
I did share the screen. I think you need to go away from Mr. Saul's slides and go onto the live streaming event. Needs to show onto the screen you're showing in the background.
Okay. Give us some minutes, please. And we are going to start. Oh. Okay. Is this your presentation?
Yeah.
Can you see rethinking skills training on the screen?
Yeah. We can see your presentation, Mike. Thank you for being here with us, and the floor is yours.
I hope you can see the screen that says Sustainable Manufacturing in Industry 4.0 Era. If somebody can just confirm that, then I know everything is working. Gracias, Señor Sal Pineda, for setting the context for this presentation for us. Good afternoon, ladies and gentlemen, and welcome to my presentation on Sustainable Manufacturing in the Industry 4 Era. A very relevant topic, I think. Briefly, the outline of my talk, we will be looking at Industry 4.0 explained, the key objectives, technologies of Industry 4, transforming the traditional model of production with additive manufacturing, sustainability in manufacturing, sustainable manufacturing with 3D printing as a solution, and of course the mobile smart factory, which Mr. Saul already alluded to, and then finally just a brief introduction to Practeria as well. So I hope you guys can all see that well on the screen. So let's begin by examining what the essence of Industry 4 is. Industry 4 is a broad vision with clear frameworks and reference architecture. Of course, it can mean different things to different industries, But at its heart, Industry 4 is an information-intensive transformation of manufacturing and related industries in a connected environment. This environment covers big data, people, processes, services, systems, and Internet of Things enabled industrial assets. It leverages data and information to realize the smart industry. The Industry 4 movement began back as far as 2011 when a high-tech strategy was presented. This strategy explained how it aimed to drive innovation, not just involving technological innovation, but also social innovation with society put at the center. One of the 5 core elements of this strategy was to create value and enhance the overall quality of life through the creation of an integrated digital economy and society. The strategy focused on a high degree of personalization of products with a highly flexible production, the inclusion and involvement of customers in design and value creation processes with connected production and high quality services. In the succeeding years, the vision of Industry 4.0 and its associated technologies has begun addressing universal challenges and possibilities across the globe. It has a part to play. Its aim is to reduce environmental impact and support corporate social responsibility through streamlined manufacturing processes and effective recycling and remanufacturing initiatives. It's important to understand that Industry 4 is not just an industrial framework. It also addresses ecological and social challenges such as resource efficiency, environmental protection, mobility, or urbanization. In essence, Industry 4.0 model of operations brings together physical industrial assets and digital technologies in so-called cyber-physical systems. Simply, Industry 4 is defined as the integration and management of primary and supporting activities in organizational, operational, and production processes and industry's value chain using autonomously communicating digital technologies. But what are the key objectives of Industry 4.0? It is the key objective is to drive manufacturing forward, to be faster, more efficient, customer-centric, while pushing beyond automation optimization to discover new business opportunities and models. The Industry 4 model can improve business operations and revenue growth, transforming products, supply chain, and the customer experience. Industry 4.0 doesn't start and end with supply chain and production, which can be much broader than that. A lot of background noise. I hope you are not all hearing that. Now, Mr. Saul alluded to some of the technologies around Industry 4, so I'll be going a little bit more into detail of those and the technologies of Industry 4. It's important to understand that there are key technologies that are shaping the way Industry 4 is implemented and approached. 9 technologies are big data and analytics, additive manufacturing, horizontal and vertical integration, the industrial Internet of Things, autonomous machines, immersive technology, the cloud, simulation, digital twins, and cybersecurity. That's better. There was a lot of background noise, I'm afraid. Going into big data and analytics, if manufacturers want to make decisions in real time, they will need data. They will collect and comprehensively evaluate this data from a variety of sources. These sources include production equipment and systems, as well as enterprise and customer management systems. These data collection and analytics practice will become a standard. If we look at an example from Tesla, who builds the electric car, they have what is called Tesla Home Services in some areas. They employ what is called Tesla Rangers, mobile technicians who make house calls. In some cases, the service is delivered remotely. The Model S can wirelessly upload data so technicians can view and fix some problems without ever physically touching the car. So one way to use data effectively in the Industry 4 era. If we move on to simulation and digital twins, Manufacturers will use simulations more extensively in plant operations to leverage real-time data and mirror the physical world in virtual models. Simulations can include machines, products, and humans. Simulations allow operators to test and optimize the machine settings for the next product in line in the world before physical production. Manufacturers benefit by reducing machine setup times and increasing quality. And just an idea about a digital twin, so a digital model of a particular product, process, production asset, which can be used for simulations. Most of the topic tonight will be around additive manufacturing. Oops, excuse me. Apologies for that. Most of the topic tonight will be around additive manufacturing as one of these key technologies. It is the process of creating objects with layers of material. 3D printers are the most common machines used in additive manufacturing. They are computer-controlled devices. They use digital design data to create three-dimensional objects in either metal or plastic. And it is still a relatively recent adoption, though technology has been growing over the last 20 years, even in additive manufacturing. But it will become more prominent, especially due to the freeness that comes with it, to design complex, lightweight designs, not usually possible with more conventional production methods. With all this data that we are creating, there's this increased connectivity, standard communications protocols that come with Industry 4, and this dramatically increases cybersecurity threats. Manufacturers need to protect critical industrial systems and manufacturing lines from these threats. As a result, they must ensure secure, reliable communications and sophisticated identity and access management of machines and users. And something we as Practeria are very passionate about is immersive technologies. So augmented reality-based systems support a variety of services. For example, selecting parts in a warehouse or sending repair instructions over mobile devices for remote support. Companies will use augmented reality more widely to provide workers with real-time information in their field of view to improve their decision-making and work procedures. VR technology, on the other hand, will be used more extensively in training in a safe environment, allowing users to become fully confident of certain processes or operations in the virtual environment before moving to the real-world situation. I hope everybody can still hear me all right. The industrial Internet of Things. So Industry 4 means that more devices, including unfinished products sometimes, will be enriched with embedded computing. The Internet of Things, or IoT, will allow field devices to communicate and interact both with one another and with more centralized controllers as necessary. IoT will also decentralize analytics and decision-making, which will enable real-time responses. Of course, we need to also store all this data somewhere. So the cloud comes into play. Production-related undertakings will require manufacturers to share more of their data across sites and company boundaries. At the same time, the performance of cloud technologies will improve, achieving reaction times of just several milliseconds. As a result, manufacturers will increasingly deploy their machine data and functionality to the cloud. Cloud computing will enable more data-driven services for production systems. And finally, autonomous machines, one of the 9 technology pillars. Robots will eventually interact with one another. They will work safely side by side with humans and learn from them. These robots will cost less and have a greater range of capabilities than those used in manufacturing today. So we've given a slight overview of these 9 technology pillars. These were the technologies that were identified as sort of the key players in moving the transformation journey within Industry 4 forward. Now we'll start to focus a little bit more on additive manufacturing, which, as I mentioned, is the layer-wise manufacturing of parts from metal or plastic, so layer-by-layer manufacturing. But how can this traditional model of manufacturing be transformed with additive manufacturing? Firstly, it will allow businesses to design and make better products replace parts that are no longer in production, modify existing parts for improved performance, enter new markets and develop new business models, and react more quickly to changing demands, and explore the possibilities of digital manufacturing. So it's really very much a game-changing technology. But before we carry on with additive manufacturing, we need to look at how is sustainability of Industry 4 in additive manufacturing. We know that the effects of global warming increasingly causing extreme weather events, rising sea levels, and disasters such as floods and droughts, with attendant economic disruption, an increase in poverty and vulnerable regions, support for sustainable development and green industries is growing. Climate change is becoming a race against time for governments, businesses, and societies. At the Paris climate change, which we all know about in December 2015, 195 countries agreed to the world's first universal action plan to tackle climate change by limiting global warming to well below 2 degrees. As the United Nations and various environmental lobbying groups ensure climate change remains center stage and high on the international agenda, more and more countries are announcing carbon neutrality targets for businesses. Do you know what this is for your country? Now more than ever, consumers and governments are holding companies accountable for the environmental impact their operations and products. Accountable for the environmental impact of their operations and products. The top places on the list of manufacturers' strategic priorities are not occupied by cost reduction or wider range of product. It is rather occupied by sustainable manufacturing, optimizing processes that minimize the negative environmental impacts, conserve energy and natural resources. It's about optimization of production processes and techniques. So optimize production methods and operations by continuously improving manufacturing operations. It's about increased energy efficiency, so low, clean, renewable energy consumption, and thereby minimize energy use in production. It's about producing less pollution, emission, and waste. So low waste disposal costs, cleaner and a safer working environment. And industrial symbiosis, which is for me a very interesting one. So to emulate sustainable natural cycles in industrial networks, where all discarded materials from one are resources for others to use. So in essence, it's about using your current resources and then being able to reuse some of your product demands in that for future generations. I will move on a little bit here. In 7 ways how 3D printing helps you to go green. So how does 3D printing or additive manufacturing help you go green? It will help you make parts locally. You can put 3D printers even in your office and make parts, prototypes, and products locally, as opposed to shipping them far away. You can have smaller, quieter factories. You can replace some of your existing equipment with additive manufacturing technology, thereby removing some of the noisy, emission-intensive technologies. You have repairability and spare parts. So 3D printers can quickly and cheaply make repair parts for unique out-of-production equipment, keeping old machines off the scrapyard. We can also eliminate inventory. So it's about printing on demand and making parts on demand, as opposed to keeping huge stocks of parts in your inventory. We use less raw material. With the freedom of design of producing parts through additive manufacturing, you can create lightweight designs using less material, and you can streamline manufacturing as well and create more efficient designs, which are more lightweight, use less material, and are structurally more stronger than any other materials available. But how does this look like when we transform this model of production with additive manufacturing? Quite simply, if you look at the graph that you can see there, conventional manufacturing, usually on large batch sizes, it has a relatively low unit cost. But in order to produce that first unit is a lot of input. It takes a lot of money and it takes a lot of resources. So the unit cost initially is quite high. With additive manufacturing, what we see is happening, especially in that red box outlined in the slide that you can see, is that we will have a reduction of production cost, we will have a lead time reduction, and we will have product improvements. And this can be valuable for prototypes in small series, mass customization, and spare parts. And just to give you some examples of that, this could be prototypes for various industries, such as the engine block shown there. It can be spare parts, such as a flange part for the oil and gas industry, or end-use parts, such as nozzles used in the rail industry. And one possible solution to drive this forward is the mobile smart factory. In essence, it is a factory housed in two mobile container units consisting of an operations container and a production container. The mobile smart factory covers the full end-to-end process for metal 3D printed parts, starting from application areas such as the different materials to be used, the digitization and programming, and pre-processing as well. So it really covers the full end-to-end process of additive manufacturing in a mobile unit that can literally be put on a truck, transported to the area where it's needed, and then you can produce spare parts on demand. So a really great solution. We also see this as very valuable for education, where the mobile smart factory can not only be used to help industries to produce end-use and spare parts, but also to help industry to create new job roles as well as are needed in industry. And this could be a collaboration between local producers, education institutions, and local communities, using the mobile smart factory as this tool for education as well as to support industry. And lastly, Practeria is here to help this transformation journey to Industry 4.0. We're a technical skills development company, and we specialize in Industry 4.0, digital transformation, and advanced manufacturing. And we work very closely with industry because it's very important to look at the industry demand in order to build new technologies, to build new skills, and the skills that are needed by industry now. I had to cut my presentation a little bit short, but I hope that you got the gist of it, and I invite you to carry on to the exhibition, to stand 507 and learn more about Practeria, but also about our partners Cargo, K Green, as well as Bionic Production presenting the mobile smart factory. And I thank you very much for your time. And if you have any questions, I'm happy to answer them. Thank you so much.